Cuckoos are brood parasites, meaning they trick hosts into raising their young. Avian cuckoos are a familiar example. The family Cuckoolidae is hugely speciose, with cuckoo birds assuming a mystifying range of forms. But the cuckoo strategy is not just limited to birds. From birds to bees, numerous animals with very different natural histories share this manipulative strategy. And with the parasites come scores of hosts, all under selection to counter a similar threat. So despite their considerable taxonomic disparity, these species can tell tales of parallel co-evolutionary arms races, and what it takes to successfully inflict the cost of parenting on another species. An avian cuckoo lays its eggs in a host nest and then leaves. The eggs, and the chicks they contain, have a suite of deceptive traits that ensures the host will accept them as their own. Female brood parasitic cuckoo wasps and bees enter a closely related host species' nest and usurp the queen. The colony is then effectively enslaved and must provision the parasite and its young. For the large blue, the situation is less familiar and more audacious. The large blue caterpillar consumes flower buds until it drops to the floor. It then begins to secrete pheromones that attract ants and cause them to carry its bulging body back to the nest. The caterpillar dupes the ant colony into feeding it as if it were one of their own. The first task for a cuckoo species is to enter the nest. This task has resulted in directional selection on the traits of attack and defense among hosts and parasites. For the hosts of cuckoo bees that have only recently been afflicted with the parasite, the association is new enough that the host has not even evolved aggression towards the cuckoos. However, hosts that have been plagued by brood parasites for longer periods put up more of a defence. In response to this, the cuckoo bumblebees now possess thicker cuticles and longer stings than their hosts to enable the parasite to breach host defences more effectively. To avoid a costly fight, some cuckoo bumblebees produce didecyl acetate, which is a known repellent of host workers. But if the cuckoo can avoid detection, there is no need for such costly fighting apparatus. Simple tricks can be utilised against evolutionarily naive species. For instance, it may be enough to approach the nest in the afternoon, rather than the morning, to reduce the likelihood of encountering the host. But for others, the hosts are under selection to be warier. Some cuckoo bees will only enter the host nest when the host female is absent, sometimes hiding nearby until it can be sure she has left. In the common cuckoo, egg laying has to be extremely rapid. The great spotted cuckoo buys time by working in mating pairs, the males calling conspicuously to draw the host away from the nest for long enough for their mate to lay its eggs. The stakes of being detected by hosts are high. Vigilant hosts who spot cuckoos may raise a loud alarm call, which attracts conspecifics and heterospecifics to join in on mobbing the cuckoo. This defence behaviour is counter-selected for hawk mimicry among cuckoos. Barred chest plumage is common, supposedly inducing fear in the host in order to reduce mobbing behaviour. Laying the eggs or entering the nest uninterrupted is only the first hurdle. Parasitism has applied strong selection for host species to be able to distinguish parasite eggs from their own, or colony members from imposters. In response, cuckoos must be able to produce believable counterfeits. The better a host parent is at recognising its own young, the more complex a counterfeit must be. Hosts of bramlings have strong rejection behaviour, so egg mimicry must be very accurate. Social insects utilise recognition centres in the form of the hydrocarbons on their conspecific's cuticle. These alkenes can occur in a number of positional isomers and so can encrypt a lot of information about colony identity. This ability means bumblebee hosts will discriminate against individuals lacking the correct hydrocarbon signatures. The greater the mismatch, the more violent the reaction. It therefore pays to become an accurate chemical counterfeiter. Some generalist species biosynthesize the hydrocarbons themselves, or the signature may be acquired through transfer once the parasite has entered the nest. As the cuckoos begin to master the art of signature forgery, the hosts are under stronger pressure to make signatures more fiendish. Comparisons between unparasitized species and host species show hosts produce less signature variation within clutches. This reduces the likelihood of recognition errors. Comparisons also show that host species produce more variation between female signatures. This will make them less vulnerable to previously successful cuckoos. Closely related, unparasitized ant species usually share very similar hydrocarbon profiles. However, the hosts, Leptothorax muscorum and Leptothorax acivorum, are unusually distinct, which suggests their signatures must have diversified under selection from their parasites. But while this escalating arms race continues, some cuckoos have begun to add more weapons to their arsenal of deception. The large blue lowers the frequencies of the vibrations it produces and increases their intensity to more closely mimic the acoustics of the colony's queen. This mimicry helps to elevate its status in the host's social hierarchy. So insects mimic host calls, just like avian cuckoo chicks mimicking begging calls. So the catalogue of techniques used by cuckoos to dupe their hosts is extensive, and the breadth of animals using these tools highlights the startling parallels between these arms races. But in all of these systems, similar selection pressures channel these eternal competitions in the same directions.